Hello, I am Lucas Emery, and my problem for this practice is chapter 22, problem number 33, and it is about a negative 12 nanocoulomb charge placed at 1, 0, and I have to find the electric field at A, B, and C, and answer that in component form. So this is the graphic that I drew. I put it on an axis to make that simple. So the charge is at 1, 0 with a negative 12 nanocoulomb charge. A is at 5, 0, B is negative 5, 0, and C is 0, 5. So the electric field is equal to kq over r squared, and k is a known constant, 8.99 times 10 to the 9th. For A, which is 5, 0, all of the electric field is in the I hat direction because it's on the same x-axis, and the radius is this point minus this point, so 0 minus 0 is 0, so I didn't add that, and I changed the centimeters to meters to follow the metric system, and we get a radius of 0.04 meters. And with that equation, we get 67,000 newtons per coulomb in the I hat, and the field points to the left because the electric field points towards a negative charge. For B, I find the radius again, B minus A, and we get a 0.06 meters as radius. Put it in the equation, and you get 30,000 newtons per coulomb in the I hat direction, and the field points to the right because, again, the electric field goes towards a negative charge. And again, that's in the I hat direction because it is on the x-axis. For C, I had to draw a triangle and split the I hat and the j hat into different components because it is not purely in the j hat or the I hat direction. And so if you look closely at the triangle, we have a 5 right there and a 1 right there. Right triangle, we can find a theta. So and x, the hypotenuse, which is, using the Pythagorean theorem, almost 0.06 meters. And we can find the theta, using tangent of theta equals 1/5, SOHCAHTOA 1/5. And the angle comes up to be about 11.3 degrees. So in the I hat direction, we have kq over x squared times sine of theta, because sine corresponds with the I hat right here, the x-axis. And so we plug that in, k times q over x squared times sine of theta. Remember, theta is 11.3099 degrees. And we get roughly 88,100 newtons per coulomb. In the j hat, we have same equation, but times cosine, because the cosine of this angle will correspond with the j hat, SOHCAHTOA. And you plug that in, and you get 41,000 newtons per coulomb. This field will point down and to the right, because, again, the electric field points towards the negative charge. And that is the entirety of the problem, solved in component form with the I hats and the j hats.